What is vertical asymptote? Now I've been asked so many times about asymptotes. What are horizontal asymptotes? What are vertical asymptotes? And how do you find them? Now we will answer this question with the help of a couple of videos. So I have 3 videos on horizontal and 3 videos on vertical asymptotes. So in the first one I'm going to tell you what is vertical asymptote. In the first video, I'll tell you what is vertical asymptote, and then I'll tell you how to find vertical asymptote, and then we'll have some interesting examples based on vertical asymptotes. And similarly, we'll do for horizontal asymptotes. So let's look for a few cases where we do see vertical asymptote, right? So I'll sketch some graphs here and show you how does it look like to have a vertical asymptote on the graph of a function, right? And what does it really mean? So 1 over x is a very good function which has both horizontal and vertical asymptote, right? So that is 1 over x. And we can have a vertical asymptote in 1 over x squared, which is kind of like this, right? That is a vertical asymptote right there. Then reciprocal of quadratic functions. These are good examples where we may have 2 vertical asymptotes. So like this. So we can have a vertical asymptote and the graph may look like this at times, right? So it could be like 1 over x on these sides. These kinds of graphs could be there where there is a vertical asymptote in reciprocal functions, right? So likewise, we can have a transformed function having vertical asymptotes. So we can have a function. Let me just transform one of these functions and show you vertical asymptote here. Now what I'll do is I will sketch a vertical asymptote on this side. Right. So what is common in all these is a vertical asymptote. So here we have a vertical asymptote which is y-axis, and the equation of this vertical asymptote is x equals to 0. Here also we have a vertical asymptote which is y-axis, and the equation is x equals to 0. In this particular case we have 2 vertical asymptotes. One, let us say this value is minus 2 for us and this value is plus 2 for us. So that becomes 2 vertical asymptotes, and one is x equals to minus 2, the other one is x equals to plus 2. And let's say this is at x equals to 1 and we have a vertical asymptote at x equals to 1. Now what you notice here is that as we approach the value of x at 0, what happens to y? This is interesting to find. So as x approaches 0, what happens to y? Now y becomes extremely large. So as you approach x, as you approach 0, from left side, so we write minus here, that is approaching 0 from left side, we find that y becomes negative infinity. Do you see that? And if you approach this same value 0, but from the right side, which is, I'm writing with plus on top of it, plus on top of 0, then we see that y approaches positive infinity. In either case, if you find that when x approaches a point, let us say x value of a, and then if y approaches plus or minus infinity, then we say that a vertical asymptote exists, and the equation of vertical asymptote is x equals to a. So that is in short the understanding of vertical asymptote. So vertical asymptote will be x equals to a means that a is not in the domain of the function. So that means a does not belong. So the point a, that means I should say x equals to a does not belong to the domain of the function. So anytime you have a vertical asymptote, then that point is not in the domain of the function. That means you can never cross a vertical asymptote, right? So that means you cannot cross, or the graph of the graph, I should say u means I should write graph cannot cross vertical asymptote, right? Because it is not in the domain of the function, right? Now in this particular case, what do you notice? As x approaches 0 from negative side, y approaches positive infinity. So you see, when x approaches 0 from either positive or negative side, we find that y approaches infinity, right? Both the cases. But it is an extreme value. It is not defined. The function is not defined at x equals to 0, and we say we have a vertical asymptote, and the equation is x equals to 0, correct? Now if you look into this particular case, you notice that as you approach minus 2, that means as you approach minus 2, if you approach from the negative side, then what happens to y value? Y approaches negative infinity. Since y is approaching undefined value, extremely large, we say there is a vertical asymptote, and the equation of vertical asymptote is, again, x equals to minus 2, the value you are approaching, correct? So in general, we can write that if x is approaching a value a and y approaches plus or minus infinity, then a vertical asymptote exists, and the equation of the vertical asymptote is x equals to a. Now here in this example, you notice as x approaches 1, and if it is approaching from minus of one side, minus means left side, then y approaches negative infinity. But when x approaches 1 from positive side, y approaches positive infinity. In either case, when you are approaching a point with x value of 1, y approaches infinity, and so we say there is a vertical asymptote, and the equation of vertical asymptote is x equals to 1. Now in the previous case, we have two vertical asymptotes. One will be at x equals to plus 2. Since as x approaches 2 from negative side or from positive side, y approaches undefined value, which is infinity, right? It could be positive or negative, right? So whenever a function approaches undefined values as you approach a point, then that means we have a vertical asymptote, right? And that is the behavior which we are talking about. So when you approach from left side here in this case, the behavior is the function gets a value extremely large but negative. But when you are approaching minus 2 from the right side, the function approaches a very large value which is positive, right? So that is the behavior near the asymptotes. But with this, now if I give you a graph, you can easily figure out where are the vertical asymptotes and what is the behavior of the function near the vertical asymptote. So from graph you can read the data. In the coming videos we will see from equation how to find vertical asymptotes, right? And then we'll have some application problems on the same. That will be the third video on vertical asymptote. Now so let's close this taking into consideration, and what we get from here is that if x is approaching a point A and y approaches infinity plus or minus, in that case a vertical asymptote exists, and the equation of the vertical asymptote is x equals to a. And x equals to a is not in the domain of the function, remember that. Therefore the graph of the function can never cross the vertical asymptote, right? Now with this, let's move on to the other two videos on vertical asymptotes. Thank you.